For 3 weeks, cameras followed this factory as a mushroom became a $2,000 designer handbag. Not a metaphor, an actual mushroom, grown in complete darkness, harvested by hand, tanned, dyed, and stitched into something you'd wear to a business meeting. No cows, no slaughterhouses, not one animal involved. Right now, workers in full protective gear are checking trays of living fungus the same way a farmer checks a crop. Except what they're harvesting isn't food, it's leather. Today we're showing you the entire process, start to finish. Stay till the end, because the way this material is actually tested will change how you think about everything hanging in your closet. For thousands of years, leather has meant exactly one thing: animal hide. Cows raised for years, slaughtered, skinned, then soaked in chemical tanning pits for up to 40 days, using toxic heavy metals that eventually run straight into rivers. That's the leather industry the world has always known. But what if you could grow leather, the same way you grow a plant? That question sent scientists searching underground, literally. Beneath every forest floor lies a hidden network called mycelium, the thread-like root system of mushrooms, spreading silently for miles, connecting trees, recycling nutrients, holding entire ecosystems together without anyone ever seeing it. Researchers discovered something remarkable. When mycelium is grown under precise conditions, it doesn't just spread, it binds together into a dense, fibrous mat. Tough, flexible, almost leather-like, straight out of the ground. That single discovery is the reason a mushroom can now become a handbag. And what you're about to see is the process that makes it possible, step by step, inside a real production facility. It starts with a single spore, invisible to the human eye. Inside massive, climate-controlled growth rooms, agricultural waste, sawdust, corn husks, leftover straw, is packed tightly into shallow trays. This waste, material that would normally be burned or discarded, becomes the food source for what happens next. The trays are inoculated with mushroom spores, sealed, and moved into total darkness. For the next 10 to 14 days, nothing is touched. Humidity is held at a precise level. Temperature never moves more than a degree or two. And in that silence and darkness, something extraordinary is happening beneath the surface. The mycelium spreads. Thread by thread, it pushes through every gap in the organic waste, weaving itself into a single, unbroken network. It's essentially building its own material from the inside out. Nature running its own 3D printer, one microscopic strand at a time. Workers monitor these rooms constantly, checking humidity gauges and temperature logs multiple times a day. Too much moisture, and the mat turns weak and fragile. Too little, and growth stalls completely, ruining an entire batch. This is a living organism, not a machine, and living things don't forgive mistakes. By day 14, the transformation is complete. What was once loose, discarded plant waste has become a thick, dense, spongy sheet of solid mycelium, ready to leave the growth room and enter the next, more dramatic phase, becoming leather. This is the moment the mushroom's life, in a sense, ends, and the transformation into leather truly begins. The mycelium sheets are carefully peeled away from their growing trays by hand, still damp, still fragile enough to tear if handled carelessly. At this stage, they look nothing like leather at all, more like a pale, spongy sheet of foam, closer to packing material than anything you'd wear. Workers in full protective gear inspect every single sheet, checking thickness, density, and any weak spots that may have formed during growth. Sheets with tears, thin patches, or uneven density are pulled from the line immediately and discarded. Because in this factory, quality control begins before the material is even technically leather. The approved sheets are stacked and moved forward into the process that will lock their structure in place forever, killing the living organism permanently and turning raw fungus into something durable enough to survive years on someone's shoulder. Traditional leather tanning takes up to 40 days and relies heavily on chromium, a toxic heavy metal responsible for some of the worst water pollution linked to the fashion industry. Mycelium leather is tanned in under 3 days, and not a single drop of animal-derived chemical is used in the entire process. First, the harvested sheets are dehydrated, stopping all biological growth permanently and locking the fiber structure in place. Then they move through a plant-based tanning bath, using natural oils and dyes that soften the material while binding its fibers into a dense, flexible structure that can bend, fold, and stretch without cracking. This is the exact moment the mat stops being a mushroom and becomes leather. The color, grain, and texture are all engineered right here. Dyes are pushed deep into the fiber network, replicating the exact look of full-grain calfskin, exotic snake print, or matte black designer leather, all from the exact same base material, grown just days earlier in total darkness. This is where it stops looking like a lab and starts looking like a full-scale industrial operation. Rows of workers in sterile white suits, not for fashion, but for hygiene, since this is still technically an organic biological product, inspect every finished sheet under bright industrial lighting, checking for consistency across the entire batch. Each sheet undergoes tensile strength testing, pulled and stretched repeatedly to simulate years of real-world handbag use. Opening, closing, carrying weight, rubbing against fabric. Thickness is measured to the millimeter. Any sheet that falls outside spec is flagged and pulled immediately. The approved sheets move onto computer-guided cutting tables, where precision blades slice patterns for handbag panels, wallet interiors, and shoe uppers. Every cut is optimized to minimize waste, and every offcut is collected and recycled back into future growth batches, feeding the next generation of material. From here, the cut panels are shipped to design houses, where skilled hands stitch, structure, and finish them into the exact bags now sitting on this conveyor belt. Visually and texturally indistinguishable from traditional leather, but grown, not slaughtered, in under 3 weeks. So the real question, does it actually hold up? Independent lab testing shows mycelium leather can match, and in some cases exceed, the tensile strength of traditional cowhide. It's naturally water-resistant, breathable, and develops the same rich patina over time that real leather is famous for. Major fashion houses have already begun quietly integrating it into limited edition collections, testing consumer reaction before scaling further. What began as an experimental lab material just a few years ago is rapidly becoming a real, functioning supply chain, one that could reshape an entire multi-billion-dollar industry. And the biggest shift of all, this process uses a fraction of the water, land, and time that traditional leather production demands, while producing zero animal waste and dramatically less pollution. Where a single cowhide might require years of feed, grazing land, and water just to reach slaughter weight, this same amount of material can be grown, harvested, tanned, and finished in under 3 weeks, inside a building the size of a warehouse, with almost no waste left over. This isn't just a clever material swap. It's a signal of where an entire industry is heading. The global leather industry is worth well over $100 billion a year, and it's also one of the most environmentally damaging supply chains on the planet, linked to deforestation for cattle grazing, massive water consumption, and chemical runoff from tanneries that has poisoned rivers in leather-producing regions for decades. Mycelium leather doesn't need grazing land. It doesn't need years of animal feed. It doesn't need a slaughterhouse. It needs agricultural waste, a spore, darkness, and about 2 weeks. That's why venture capital firms and major fashion conglomerates have quietly poured hundreds of millions of dollars into scaling this exact process over the past few years. Not because it's trendy, but because the math, the environmental cost, and the consumer demand are all pointing in the same direction. So next time you see a $2,000 designer bag, look a little closer. It might not be a cow. It might be a mushroom that grew in complete darkness for 2 weeks, harvested by hand, dyed, tested, cut, and stitched into something you'd never think twice about wearing in public. This is the hidden process behind fashion's quietest revolution, happening right now, inside factories most people will never see.